It's Wednesday, June 24th. My name's Juan Brown. You're watching the Blanco Lirio channel, and breaking news, the preliminary report on the tragic loss of Pakistan International Airlines Flight 8303 is made public today. And everything we've been following about this accident so far appears to be spot on. However, this report adds some additional detail that indicate that this accident may very well be the worst case of human factors failings that I've seen in commercial aviation history. Let's go inside and take a close look. It's only 14 pages long.
Okay, here's the preliminary investigation report just made public today. We're going to be using all these different tabs up here to help explain this report as we go along. Here's the aircraft in question before the accident, long before the accident, table of contents, list of figures, abbreviation and codes. We'll get into this. Some of the abbreviations are a little different than that which we're used to. Open descent, we'll be talking about that as a Airbus specific item. Acknowledgements, again, this comes straight from Pakistan, but they give thanks to the BEA, the Bureau of Inquiries and Analysis from France, and the NTSB, National Transportation Safety Board here in the United States were involved with this, as well as Airbus, Safran Engines, General Electric, all helped out in this investigation. Preliminary report, brief description on 22 May 2020 at 13:05 hours local time. Pakistan International Airlines aircraft Airbus A320-214, registration number Alpha Papa Bravo Lima Delta, took off from Lahore, Pakistan, to perform a regular commercial flight to Karachi as Flight 8303. 8 crew members, 1 captain, 1 first officer, and 6 flight attendants, 91 passengers on board. At 14:35 hours, the aircraft performed an ILS approach for runway 25 left and touched down without landing gears. In other words, touched down without the landing gear extended. The landing gear was retracted, or it was in the up position. Resting on the engines. Well, it didn't come to a rest on the engines. It did a scrape and go, as I call it. Both engines scrubbed the runway at high speed. Flight crew initiated a go-around and informed Karachi approach that they intended to make a second approach. About 4 minutes later, during the downwind leg at an altitude of around 2,000 feet, the flight crew declared an emergency and stated that both engines had failed. The aircraft started losing altitude. It crashed in a populated area short of runway 25 left by about 1,340 meters. An immediate subsequent post-impact fire initiated. Out of 99 souls on board, 97 were fatally injured. 2 passengers survived. On the ground, 4 persons were injured. 1 subsequently succumbed to their burn injuries. Next is the composition of the investigation team, and this was under some scrutiny by some of the folks there in Pakistan. The first 4 members of the investigation team are Pakistanis, and it looks like at least 2 of them, perhaps all 4, are members of the Pakistani Air Force, military folks. In addition to the 4 Pakistan investigators, 2 investigators from the BEA in France, that's these folks here, the Bureau of Inquiries and Analysis from France, and 1 from the NTSB, National Transportation Safety Board, here in the United States. 5 other members included 2 A320 pilots, 1 doctor, 1 aviation psychologist, and 1 A320 engineer. Scope and purpose of the investigation. The sole objective of the safety investigation is the prevention of accidents and incidents of a similar nature. It is not the purpose of this safety investigation to apportion blame or liability. This information is published to inform the aviation industry and the public about the general circumstances of this event. Extracts from this preliminary report may be published without specific permission, provided that the source is duly acknowledged and the material is reproduced accurately in its original content. And that's what we're doing today. We're referencing the exact preliminary report from the Pakistani officials. This is a preliminary report, and it contains facts which have been determined up to the time of publication. It also provides a brief overview of the investigation process. So typically here in the States, they start out with a preliminary report on one of these accidents such as this, and then usually about halfway through the accident investigation, the NTSB comes out with a public docket. That public docket contains all of the data that they have collected for the accident. That process, halfway through the investigation, usually takes about a year after the crash. And then finally, another half a year, maybe a year later, up to nearly 2 years total time since the crash, here in the States, the NTSB finally publishes its final findings from the accident and determines the probable causes of the accident. With this accident in Pakistan, I'm not sure if they're going to have that public docket interim step, or they're just going to go straight to the final investigation report once they wrap this up. Custody of records of aircrew, ATCOs, air traffic controllers, and the aircraft. Aircrew records related to their medical fitness and licensing were taken into immediate custody from relevant directorates of the CAA. Similarly, their training records and personal documents were collected. All these documents are in the custody of the investigation board. Additionally, information about crew scheduling, rest periods during the last month and during the last 72 hours were collected by Pakistan International Airlines. This is going to be critical information to find out what state of mind, what were these guys thinking. This is all going to come down to a human factors. That human factors is how well rested was this crew and what were they thinking. Same with the air traffic controllers. They got their licensing, their training, and their medical fitness information. All the aircraft technical documents, logbooks, and that sort of thing were gathered up. Here's the specs on the aircraft. Airbus A320-214, serial number 2274, built in 2004 with the CFM 56-5 BP4 engines with the serial number type. Serial number types are important because that determines airworthiness and their any applicable airworthiness directives, which go by serial number. Total flight hours, this is kind of unusual, 47 hours. I assume this is 47 hours for the left engine or number one engine, and 124 hours on the number two engine, the right engine. I assume those would be hours since major overhaul or hours since the last major inspection on these aircraft engines. Total flight cycles on the I'm assuming on the left is only 25, and on the right 866 flight cycles with 124 hours total time. That doesn't make a lot of sense to me at this time, but in the end it's not going to really matter. Investigators are going to find out that there was nothing wrong with these engines until they were smashed onto the runway. Crash site. The crash site is located in a residential area northeast of the airport. The wreckage lies approximately 1,340 meters from the end of 25 left threshold, close to the extended runway center line. So here was the wreckage right here. They were so close to making it back to the airport before both engines failed and put them into this neighborhood right here. The aircraft parts were spread out over 75 meters on a single street. We got some photographs to show you here with some parts on rooftops of adjoining houses. So the wreckage, of course, went this direction from east to west as they were lining up for 25 left. Aerial view of the crash site from the street. So in this case, in this picture, we're looking at the crash flying into these buildings from left to right. So the left wing and left engine ended up here on the top of the buildings, and then the aircraft rolled down into the alley or the street below here, finally ending up over here. This indicates to me a very low-speed crash. The pilots were still struggling to fly the aircraft up to the very end. They approached this crash at the slowest speed possible. They may have very well been stalling right into these buildings. Map and identification of aircraft parts. In this photograph, the wreckage is shown, or the direction of flight is going to be from right to left. So the initial impact point, A, is here on the right, and then the final bit of wreckage out here at I. Let's look up what some of these different major components are. So starting with A is the impact point. B is the right-hand side main landing gear, located right here. C is the number one engine and left-hand side of the wing. I believe was on these rooftops right here. We'll see in subsequent photographs. D is the vertical tail, located right here. E is the APU cone, right there. F is engine number 2, the right-hand engine, located right in there. G is the cockpit area, just off to the left. And I, some more avionics located right over here. So to me, this indicates that the aircraft was completely intact as it impacted these buildings and this alleyway. Here's the various lists of all the additional bits and pieces located inside this photograph. Looking down at the street, the eastern side of the street, number 2 is the APU inlet right here. From this, they can gather whether the APU was running or not. Number 4 is the horizontal tail, left and right sections. Number 5 is a section of the left-hand wing. And it looks like there's a motorbike smashed underneath there as well, just parked on the street. This is some astonishing new photographs coming from this investigation. This is looking down the alley towards the direction of flight. Number 16 is a right-hand section of the wing down here. E is the APU cone located down in here. F is engine number 2, which we've seen in other photographs. Engine number 2, we're looking at the back side of engine number 2 here. We'll get a closer view of that. H is a right-hand section of the wing. And now we turn the camera around and look the other direction. We're looking towards the east, from which direction the aircraft came. And way up here on these rooftops, C is engine number 1 and the left-hand section of the wing, probably the outboard section of the left wing. So the left wing and engine hits these rooftops here, and then the aircraft falls and rolls off to the right into the alley below. Number 16, again, that right-hand section of wing. E is the APU cone. Number 18, the trimmable horizontal stabilizer jack screw is located right here in number 18. Number 12 is the fuselage panels. Number 20, cargo door and aft fuselage right there. And the number 2 engine, the engine on the right-hand side of the aircraft. And we've seen pictures of this engine before. Paragraph 12, it explains a lot as to the configuration of the aircraft on final impact. The layout of the aircraft parts on the accident site is consistent with the aircraft impacting buildings on both sides of the street at low speed. The trimmable horizontal stabilizer actuator position before impact was determined to be at 2.8 degrees nose up. This is a normal condition. That's a normal trim setting for this configuration of the aircraft. According to the rudder travel limiting unit, the aircraft's speed before impact was below 150 knots indicated airspeed. Okay, so there's a lot going on here in this sentence. Commercial aircraft, large twin-engine aircraft, require that the rudder have different control throws based on what airspeed the aircraft is flying. At low airspeeds, a twin-engine transport category aircraft needs a large degree of control authority so that in the event of an engine failure, you have enough rudder authority to counteract the adverse yaw of an engine failure. So at low speeds, you need a high amount of rudder throw. At high speeds, you need a limited amount of rudder throw so that you don't overstress the aircraft if in the event that you were to give it full rudder authority at high-speed flight. So the rudder control is limited by airspeed. So because of reasons we'll discuss in a minute, investigators had to reverse engineer to get this speed of 150 knots by looking at the rudder limit actuator. What it was set at indicated to investigators that the speed was below 150 knots, which allowed the wider range of rudder throw that's available at those lower airspeeds. We'll discuss why they had to get this data from the rudder travel limiting unit instead of the FDR in a moment. Several findings indicate an extended landing gear configuration at the time of impact. The free fall mechanism for the lowering of the landing gear was not used. So the crew did manage to lower the landing gear using normal landing gear, just by lowering the landing gear, by lowering the landing gear actuator on the instrument panel. In other words, there was nothing wrong with the gear. The slat flap configuration was determined to be in position slat 1, i.e. 18 degrees, flaps fully retracted 0 degrees. The flaps 1 position on the Airbus, like many of these commercial aircraft, the flaps 1 position only gives you leading edge slats. The leading edge slats deploy and the flaps remain retracted. That's flaps 1. The RAT, or the ram air turbine was seen deployed on the CCTV, the closed circuit television screenshots prior to impact. And also those photographs from the Pakistan observers that we've been talking about showed the RAT deployed, the ram air turbine. And as discussed in previous updates, that indicates to me that both engines were failing. The ram air turbine, the emergency electrical power system on board the aircraft sensed that both main AC generators were shutting down and thus deployed the ram air turbine to provide emergency electrics and emergency hydraulics to keep the aircraft flying. It doesn't say in this report yet whether the RAT was manually deployed or automatically deployed, but I can bet you nearly 99% that this RAT was deployed automatically as per the automatic design features built in to the Airbus. The left engine showed evidence of external fire. Visible fan blades condition was consistent with the engine being at low rotational speed at the time of impact, most likely not producing any thrust. And we talked about this in previous updates. By looking at the photographs, you could see there was a minimal amount of damage to the high pressure or to the high bypass fan section, indicating that these engines were at a very low or no power setting on impact. Because normally, the engines are under power. Those blades just twist up like crazy on impact. Right engine showed evidence of external fire. These external fires are mostly likely from the fire that ensued after the crash. Fan blades were in good condition, being consistent with the engine at low rotational speed at impact, most likely not producing any thrust at the time of impact. So this is consistent with both engines failing. Paragraph 14, transfer gearbox and drain mast reservoir located at the engine lower part showed marks of friction with the hard flat surface, i.e. the runway, material displacement and loss of material. It was consistent with the closed-circuit TV footage. By the way, we got a photograph from the closed-circuit TV footage, but we don't have the actual footage itself yet. And this was a big question. Wasn't there photographic evidence of the landing on a closed-circuit TV at the airport? And apparently now we know that the answer is yes. They just hadn't released it. It was consistent with closed-circuit TV footage showing the lower part of the engine scrubbing the runway during the first landing attempt. The APU air intake flap actuator, which we found in the photograph earlier, was not in the retracted position, consistent with the APU not being used at the time of impact, i.e. not supplying electrical power and bleed air pressure. So this crew did not manage to get the APU up or running. The APU, the auxiliary power unit, which can supply more than just emergency power to the aircraft, bleed air, and some hydraulic pressure. So in this case, in the final seconds of flight, after the engines failed, this aircraft was relying on the ram air turbine to provide the electric and hydraulic power needed to keep this Airbus flying. Paragraph 15. Some parts recovered on the runway 25 left were identified as CFM56-5B engine and A320 nacelle parts, consistent with the closed-circuit TV videos of the airport showing the lower part of the nacelle and engines impacting the runway during the first landing attempt. And we'll take a look at those pictures here in a second. Okay, we're 20 minutes into this, and I'm only halfway through the report, so I'm going to break this video into two segments. In the second half, we're going to talk about the data that was recovered by the accident investigators and the flying stuff, the flying part of this accident investigation, compare what this crew did along with the actual ICAO approach plates for the Karachi airport. So thanks so much for your support. It's the folks over here on Patreon that make this detailed level of reporting possible here on YouTube. Thank you for your support over on Patreon. See you here. See the link below for part 2.